So graphs, our concept today is DPP 4.6, but we are going to understand what are graphs in motion in a straight line. There are several types of graphs. Out of them, graphs in motion chapter. This is what we're going to do now. Graphs. I told you three types of graphs are widely there are three variations of graphs. And those three variations of graphs are on the x-axis always time is there. On the x-axis there is no change. X-axis always time. Y-axis things will keep changing. Right? I told you that yesterday. X-axis always time because time is a parameter. I told you time is neither a vector nor a scalar. It is a parameter because it doesn't have negativity. It always has positive. On the x-axis we could have displacement x. Displacement is represented either by x or in some graphs s. On the y-axis we could have velocity. Now you don't get confused velocity and speed. It's velocity only, not speed. Velocity. And on the y-axis we could have acceleration. These are the three types of graphs we started yesterday. The graphs could be, I told you, like just from origin. They could be like this. Or the graph could be, what are these? Oh, okay, let us deal with this y is equal mx type of a graph. So here y is equal mx means x is equal to some m into t. That is the graph equation. Here velocity v is equal to some m into t. Is it or not? Here acceleration a is equal to some slope m into t. Is it or not? What is the slope m in this situation? It is dx by dt. Is it or not? It is nothing but dx by dt. So the slope of a displacement time graph is nothing but velocity. Is it or not? The m, the slope is here velocity. Here what is m? I'm calling this as m1. What is m2? What is m3? m2 is dv by dt. Is it or not? Which is nothing but your acceleration. Of course, there is another name for this m3 is nothing but dA by dt. There is no name for dA by dt as of now in your books. There is no name, but rate of change of acceleration. We call it as rate of change of acceleration. But there in physics, higher level of physics, there is a name that is called jerk. Jerk, jerk. Okay. Now, this is how the graphs could be, or the graph could be a straight line parallel to x-axis. It would be just a straight line parallel to x-axis, like this. What does that mean? What does this straight line parallel to x-axis mean? It means that with time, there is no displacement change or the displacement is constant. What does this mean? That means displacement is constant means the body is at same point. It's at that same position and is maintaining the same position. So it is like a rest. Here if you see purely rest, velocity is, this is not purely rest. What do we call this as? Velocity, constant velocity, because whatever the time may be, same velocity, constant velocity. Here what is this? Here constant acceleration. That's what it means. Is it understood? This means rest. What does this mean? This means constant velocity. Is it or not? V is equal to C. Constant velocity V is equal to C. What does this mean? Constant acceleration. Constant acceleration A is equal to some constant C or K or something like that. Is it understood? So the third type of a graph which we were saying, which is the most important type of graph. The graph could be like this, or here also. The graph could be like this. Graph could be anyway starting from some point. Initially, there is a displacement. This graph and this graph doesn't make any much difference. The earlier graph y is equal to mx. or x is equal to mt. What does x is equal to mt mean? That means velocity is constant. Here, what is the meaning? Velocity. The body is moving with a constant velocity. Is it or not? The body is moving with a constant velocity v. It's because the slope is a straight line and the slope is a so the equation is a straight line and the slope is a constant slope maintaining. Is it or not? The slope theta is constant. The slope theta is constant. Here also the slope theta is constant, doesn't change. That means constant velocity. Here what is the constant here? This equation represents constant acceleration. This equation represents constant jerk. Okay. Now, this line and this line are parallel to each other. Only difference is they start from a point. So, start from a point means initially there is a x initial. Here, what does it mean? There is a initial velocity. Here, what is the meaning? Initial acceleration. Here, what is the initial velocity? What is the initial position? Zero. The body
Zero,
starts
sir.
from origin. Here, the body starts from rest. That
I think the initial will be any number, sir, like 1, 2, 3, like that.
this is like some number. Here it is. Here it is. Here
Yes, sir. Yes,
zero.
sir.
Zero means it is some home, starting from home. Here the body is not starting from home. It is already starting from some point. Beyond the home, you are starting from your auntie's house. That is here xi means. Here what does it mean? Here you are starting from rest means you started uh, kick the scooter, then start from rest means initial velocity u is zero. Here initial velocity is not zero. What does it mean initial velocity not zero? If you are able to drive bike, then you will know. You just start the bike, press the brakes and give an acceleration, then you just leave the clutch. Suddenly what happens? It will have initial velocity, no? Suddenly initial velocity will not be zero. It will not start from zero. It will start from 60, 30, something like that. You can see your speedometer suddenly going to 30. Understood or not? That is the meaning of initial velocity. Now, what does this here mean? Initial acceleration is zero. But here, initial acceleration is non zero. Okay, that is what it means. Okay, this is what. Okay, these are the three types of graphs. And we have, shall I wait for you or can I go ahead?
Sir, can you explain once x is equal to mt and v is equal to m2t and a is equal to m3t, sir?
This is x is equal to m1t, m1t, not m1, m2, mt, like that. X is equal to mt because this is a straight line, no, linear line. Y is equal to mx equation, you forgot. Y is equal to
Formula for slope, sir.
straight line equation. In 10th standard they taught y is equal to mx. So this is like x is equal to y is like x. X is like t here. You don't know that equation of straight line? Math student you are. Y is equal to mx line.
Yes, sir.
There is plus c, then this is the equation. This is like y is equal to mx plus c. That c
Yes,
is a
sir.
positive constant. Here, if you write that as an equation, x is equal to, what should I write? Mt plus c. What is that c? Xi. C is like xi. Understood? Here, if I write that
Yes, sir.
equation, v is equal to mt plus initial velocity u. Here, if I write a is equal to mt plus initial acceleration ai. Is this understood? Huh?
Yes, sir.
So we go ahead and rub it off.
Wait a minute, sir. I'm copying, sir. Wait.
Now, since these are the types of lines and graphs which we can have, but we have already derived the equation of s is equal to ut plus half at square. Is it or not? Then will that be one of these lines? No, it will not be. If you see s is equal to ut plus half at square, and we know that acceleration is a constant in this situation of this equation. Acceleration is constant. If acceleration is constant, if you observe this s is proportional to t square. So this is a parabolic equation. This is a parabola and it starts from ut. Doesn't start from 0 plus at square. If this s was like this, 0t means initial velocity is 0 plus half at square. If it was like this, then your equation would be like this, a parabola. But general equation is s is equal to ut plus half a t square. So how it will look like? It will look like this. And what is this? This is initial xi. Generally, x s. How do you write s? Xf minus xi. This is called as s is equal to ut plus half at square. So if I want to write xf, what will I write xf? Xi will come this side, right? Plus ut plus ut, because this equation is very important for solving a lot of problems, a parachute, balloon problems. We're going to solve now. Balloon problem, parachute problem, aeroplane dropping a bomb problem, all the problems. This is very, very important. Height of tower problem. Okay. So this is a parabolic equation, parabolic curve, sorry, parabolic graph. This is a parabolic equation, parabolic curve. It doesn't have this side anything. I hope you know that, because there s cannot. Why will it not have anything this side? Because time cannot be negative. That is the reason. Here xi is 0. Here xi is non-zero. It starts from an initial point. Now the slope of this curve at any point, you are taking the slope at any particular point. If you find the slope, how do you find the slope? At a particular point, you want to find the slope. You have to draw a tangent at that point. You have to draw a tangent at that particular point. It's not clear. You want to find the slope at a particular point, you have to draw a tangent at that particular point like this. For example, I will draw a tangent just touching one point. Now see, this is the point it is touching. So this is the tangent drawn at that particular point. So at that particular instant of time t1, it was traveling with a particular velocity. Since it is at a particular xi, so that means dx by dt is the slope, which is the instantaneous velocity, which is the instantaneous instant, which is the instantaneous velocity. Instantaneous velocity is the instantaneous velocity of that particle at that particular instant of time. But if you want to find out the average velocity, how do you find average velocity? You take 2 points. You have to take 2 points. Then only you can find the average velocity. How do you find average velocity? That I will tell you. Can you rub it off? Forgot recording it.
No, sir,
Oh, sorry, no. Yes, I will repeat. I will repeat. So you want to find out the instantaneous velocity at another point, this pink dot. How do you do find out the instantaneous velocity at this another point? You have to put draw a tangent at that point. You observe this theta 2 is greater than this theta 1. Is it or not? This theta 2 is greater than this theta 1. So V2 is dx by dt at T2. At T2 is equal to tan theta 2. And this is tan theta 1. Did you get this difference? Huh? Tan theta 1 is different from tan theta 2. Because tan theta 2 is greater than tan theta 1. That is because of V2 is greater than V1. This is the instantaneous velocity at T2. This is the instantaneous velocity at T1. Is it understood? Now we will go to the concept of average velocity. Average velocity is totally different from this. We need 2 points to find average velocity. We don't need 2 points to find instantaneous velocity. Instantaneous velocity we can find by using at one single point only. But average
Sir,
velocity needs 2 points. Yes.
sir, for average velocity, we have to take the average of two instantaneous velocities, sir.
We need to take 2 points and find out the slope between them by using the earlier 10th standard formula. I will tell that now.
Okay, sir.
Can I rub this? Not so.
1 minute,
Wait
sir.
a minute, sir. Wait a minute.
Huh. So average velocity, how do you find average velocity? Means again draw the lines. Again draw the graph. That's better. Here, find out the average velocity. Did you understand? These are two different graphs. Here S is 0, here S is having some initial xi. Okay. Both I am making you understand. Average velocity is between 2 points. Okay. 2 points or two instantaneous velocities, we can say that way also. That is also correct way of understanding only. So this is one instantaneous velocity, this is one instantaneous velocity. You want to find out the average velocity between those 2 points of time. Okay, this is one instant of time, t1, where you found out one instantaneous velocity. This is one instant of time t2, where you found another instantaneous velocity. Here you found that the slope was v1, and the other place you found that the slope was v2, by using the slope formula. Now I want to find out the average velocity between this point and this point. How do you find that? Is the average velocity is given by the formula total distance between T1 and T2. Okay, between T1 and T2. That's very important. Total distance or displacement. Total distance or displacement. You can write like that. Distance or displacement covered between. I'll drop that. Covered between T1 and T2. Between the times T1 and T2. Divided by total time interval. Total time interval between T1 and T2. Time interval of time interval between T1 and T2. Time interval means it's understood clearly. T1 and T1, T2 minus T1 is T. So if you write that as a formula, it will be what will this distance? You see this? This line, this curved line I want to find out. How do I find the curved line? It is some S I do not know. Divided by some T. S by T. It is actually T1 minus T2. It is nothing but T2 minus T1. That is the time interval. How do I find that? So for that, what is the best way to do is you have to find out these coordinates x1, x2, and you have to take this t1, t2, and then what are you going to do? Delta. There is another operator called delta. That is difference operator. It is not. Have you copied this? Or
Yes,
I
sir.
have made it here only. S
Wait
is
a minute, sir.
what is S here? So what is S here? I will. S is the displacement, no? Is it or not? From this point to from this point, see how I am joining this. Are you able to see? This is a straight line I've drawn. Okay, I'll take another color. Okay. From this point, I will use. This is my S. Did you understand? This is my S. The straight line. The displacement line is S. How do I get that? Means simply x2 minus x1 by t2 minus t1. Okay, or this can be as well written as delta x by delta t, change in the displacement or change in the position by change in the time. Is it understood? That's called as average velocity. Is it clear? Average velocity is got by this curve. We cannot get average velocity from any other curves. Okay, you have to remember that average velocity cannot be found out from velocity curve. We cannot find average velocity from average acceleration curve. No. Is this understood? Okay. As we were saying, you can as well draw a line, a curve this way also. Could have a curve s x versus t only, but you could have had a curve like this, means, or a line. You could have. Why is it coming like this? You can have a line like this also, or you could have a curve this way, means this way also a curve can be there. These are also special curves, not special in any way. What does this represent? The initial position vector was xi, Okay, initial position vector was xi. What is happening here? Velocity is negative, is it or not? Is it or not? The slope is negative slope. Is it or not? Are you understanding that? Because this angle theta is obtuse angle. Obtuse angle means more than 90. Okay. Obtuse angles, what is tan of 90 plus theta? Just see. Do you know mathematics? Tan 90 plus theta is minus cot theta, man. So what you will get is a negative answer, negative slope. Negative slope means velocity is negative. Okay, xt curve has a negative slope. That means velocity is negative. So that's why velocity being negative, what happens? That means initially the body was starting at some point, and due to the negative velocity, slowly it will come to rest. Is it or not? After some time, after time t is starting from t is equal to 0 second. What happens with due to negative velocity? It will come to rest. This is the resting point. Is it understood? Hmm? Right. And what about this curve? What about this curve? Very important. This is also negative curve only. Okay. How is it a negative curve? Let us understand that very clearly. We have to draw the tangents at every point to understand whether these are negative or positive or whatever we say. Take 2 points. Take different points, and then at different points draw the tangent. This here. At this point, if I draw the tangent, how will I draw a tangent? The only way I can draw a tangent is take a straight line at that point. You know. See, tangent should not touch the curve at more than one point, only one single point. Is it clear to you? Tangent should not be like touching many points. That's why it is not so easy to draw tangents. Ah, yes, yes. Yeah, okay, like that. Yeah. What is this? No. Ah, yes. Now see this curves. Now see these curves. At point, now see, at T1, T1 is a small time. Is it or not? T2 is a higher time. Is it or not? T3 is a even higher time. Is it or not? T3 is more than T2 is more than T1. Yes? But if you see the thetas, so at T1, what is theta? Theta 1. At T2, it is theta 2. At T3, it is theta 3. Which is more? Theta 1 is more than theta 2 is more than theta 3. Actually, when time proceeds, what should happen? Theta should increase, but thetas are decreasing. Is it or not? This clearly signifies that the velocity is decreasing because tan theta 1 is more than tan theta 2 is more than tan theta 3. That clearly means V1 is more than V2 is more than V3. That means velocity is decreasing. Is it or not? This clearly means that velocity is decreasing. Maybe there is a retardation in this curve. That's why velocity is decreasing. Slowly with time, velocity is decreasing. That is because there is a retardation. Okay. And finally the body comes to rest. Okay. This is the significance of these type of curves. When the curve is upper parabola, it is a accelerating curve with velocity keep on increasing. When the curve is a lower parabola like this, then this is a decreasing parabola, or the velocity is a decreasing and retarding curve. Is it understood? Hmm. You can note that if you want. So I have to draw this curve properly. So at this point I want to draw the tangent. How do I draw? Like this. Is it or not? Of course, imagine the I can't draw it outside my laptop, so it will be somewhere outside. It'll cut somewhere there. Here at this point, I want to draw the tangent. Okay. Similarly, at this point, which point am I drawing? Here. Okay, here I will draw man. Some other point I will take. No, better. This is my point. This is my point. Okay. Like that, I keep on drawing. What do I observe? See, how do you observe first of all? Take times first. T1. And by the way, there is one special point here. At this point, I will draw the tangent. You see what will happen. This will be a straight line. Is it or not? Parallel to x-axis. The tangent will not cut the x-axis anywhere. It will be parallel to x-axis. Now, what are all these points? What do they symbolize? We will understand. This is my point x1, x2, x3, x4, x5, somewhere point this is x5. And these are corresponding times t2, t3, t4.
Sir, the
Very
last one is X3, X6, I think, sir. X6.
no problem. This one x6, x7. So many you can write. Here also I will write about those points. Wait. First see.
This one, sir. After 5, sir, you wrote again 5, sir.
T5, T6. Okay. What are these points telling you? The just see the slopes first. How is this slope? Okay, first about this thing. This is theta 1. Is it more? Theta 1 is increasing, no? Theta 2 has increased. Theta 3 is even increased. Is it or not? Here, see, theta 1 is less. Then theta 2 is more. Theta 3, theta 1, theta 2, theta 3, like that increasing. And finally, what happens to the theta? What happens to theta? Can you tell me? Theta, can you tell me? Think
It
and
will
tell
be
me.
equal to 0, sir.
No? Will it be equal to 0?
No, sir, it will be negative, sir, because the line is
At
going
this
down.
point, what is the slope? At this point. Here, theta increased, you are telling no. This is increased. No, this is
Yes,
not
sir.
20, man, 20, 30, 40, 50, like that. Slowly it increases, is it or not?
0, sir. I think it's 0.
What is the. No, you are saying 0, man. This is 180 degrees theta.
Okay, sir. Okay, sir.
With y x-axis, this is. Acha, you mean this line is not cutting the x-axis, so you are saying like that 0 degrees. Okay.
Yes, sir.
Not the only way to understand the slope. Slope means the theta. You should see the theta. If you see this theta, see this theta. Theta increase, increase, increase. No, this has increased, increase, and finally here the theta. Okay, you can call it as zero, either 0 or 180. So,
Okay, sir, since it's parallel, you're saying 180, sir.
yeah, that's what. The line has become parallel. Is it or not? Hmm? Now at this point, what happens to theta? Tell me. Little less than 180. Is it or not? Little less than
Yes,
180,
sir.
some 145, 185, 1 not 185, 170 maybe, could be. Or this angle will be how much? How much will this angle be? Even less. Is it or not? Understanding what I'm saying?
Sir, I think
Slowly,
the last one will be 175 like that, sir. Because it's steeper, sir.
but I will tell you now one important point. You have to understand that. Let me draw this not neat. I will draw it neater. Wait.